This is a little tutorial about phase changes, temperature, and energy, and how they're all related. Phase changes are a really interesting part of physics, as in because they require a lot of energy or give off a lot of energy depending on which direction they're going. We're going to be able to tell how much energy they give off based on the phase change and also based on temperature changes here. The first thing, when we talk about phase changes with water is what we're mainly going to be dealing with, because that's the easiest thing to work with and it's the most common thing we deal with in physics and chemistry. There'll be 5 different steps to going through all the phase changes. If you go through all the different phases and phase changes, there will be 5 steps. Now you might not always go through all these phase changes. We're going to talk about the temperatures at which water goes through these phase changes at standard pressure. So the first one, right here we have ice. Water is ice, or H2O is ice, at anywhere from -273 we're going to erase that. Anywhere, we'll just say anything less than 0. It's ice. Anywhere from, it melts ice at 0. Then it turns to water, and we have to heat water from 0 to 100. So anywhere from 0 to 100 degrees Celsius, we're going to be heating water. At 100, we're going to boil and evaporate it. And then anything greater than 100 is going to be heating the steam. And those are basically the 5 steps. If it starts at anything below 0, we're going to have to heat the ice. If it ends anywhere after 100, you're going to have to heat the steam. So you'll have to go through every single step. If you go from ice anywhere below 0 to anywhere after 100, you'll have to go through each one of these steps and add them all together. So remember, we're going to be adding these all together, not timesing them. You'll be timesing each individual part, but you're not going to be adding them each together. For example, heating the ice is going to be, you take the specific heat of ice, so C times the mass times the change in temperature. Same thing with this. With heating the water is C times mass times change in temperature. And then with steam, it's C times mass times change in temperature. Each one of those masses are going to be the same in any given problem, but the C is going to be different for the ice. It's going to be different for the ice, for the water, and for the steam. As I gave you on that reference sheet, C, or the specific heat for ice, is 2.1. Specific heat for water is 4.184, and specific heat for steam is 1.996. Also, we're going to need to do the phase changes. To melt ice, it takes 334 joules per degree Celsius per gram. So 334 joules times by the amount times by the mass. So that's for that. And then to boil evaporate water, it is 2,260 joules per gram. So you times that by mass. So there's a lot of energy involved in melting and evaporating. That's actually where most of the energy is going to be if you do any melting of ice or evaporating. It doesn't take as much to change the temperature as it does to boil or freeze it. Actually, freezing gives off to melt it or boil it. And then you have each of these individual parts. So if you're going through all the steps right here, you're going to end up timesing everything inside here together, inside these individual ones, and then in the end, though, you will add all these different equations together to get your final answer. Well, let's say you're only going from -50 to 50 degrees. In that case, you would only end up doing the one from -50 to 0. So that's this right here, heating the ice, right here, and then you'd end up doing the melting, which is 0 at 0 degrees. You take 334 times by the mass, and you'll end up heating the water up to 50. So you're going to take 50, you take your specific heat, 4.184, times it by the mass, and times by the change in temperature, which will be 50. But if you're doing all the steps, let's say you're going from -50 to 150, you'd have to go through each one of these steps here and add them all together over on the side, all these different things. So it's not real complicated, just a lot of little things. Addition and subtract, only addition and multiplication, nothing else. So just a bunch of additional multiplication. Let's do a quick practice problem with that. We have ice at negative 40 degrees Celsius, and we want it to go to steam at 150 degrees. So in this one, you're going to have to go through every step. So at ice at negative 40, first step we have to go, we look back and we have to heat the ice. So we go from negative 40 to 0. So that's going to be a 40-degree temperature change. The specific heat of ice is 2.1, so 2.1 times 40 times mass. I actually forgot to include a mass. We'll say it's 50 grams here. Times 50. Okay, that's our first step. Then we need to heat it we need to melt it. So we're going to take our 50 grams, times it by our heat of fusion, our energy required to melt it, which was step 2, which is 334. That's our second step. Then we have our heating the water, and we're going to heat the water we're going all the way to 150, so we're going to go through the whole range of water, which is 0 to 100, so our change in temperature is going to be 100. Specific heat's 4.184. Let's actually redo this. We'll write specific heat first, so specific heat's 4.184. Our change in temperature is 100, and our mass is 50. Oops, not 500. Okay, that's our next step. Fourth step is we're going to need to make it to steam. Steam is going to be, we're going to be at 100. We'll take our mass, which is 50, and times it by 2,260. And then the last step will be to heat the water to 150. Heat the steam to 150. It's at 100, so we have to go up 50 more degrees. So the specific heat of steam is 1.9996 times the we'll say times the change in temperature, which is 50, times the mass, which is 50 as well. Okay, we'll do that, and then the last thing we do is we're going to add all these together. And when we do that, we'll get our answer. So as you can see here, I went and calculated each step and how much energy was required. First one is 4,200 joules, so that was the heating of the ice. Second one was 16,700 joules, that was the melting of the ice, so it took quite a bit of energy. Third one was the heating of the water. We had to heat it 100 degrees, so it took about the same as, just a little more than melting the ice. And then the fourth one right here, that was boiling. That's the one that takes the most temperature, the most energy of all. It's 113,000 joules just to heat boil that water. And then the last step to heat it to 150 was 4,990. And when we add all these together, we get 310,160 joules of energy required to heat that water from negative 40 to 150 degrees Celsius, so that 50 grams of water. That's quite a bit of energy. Let's see. It's right around almost 100 calories, so about the energy of a candy bar that's in a candy bar.